So in example 2 of our notes for direct variation, we're asked to write and use a direct variation equation. So we're told y varies directly with x. That means the equation is in the form y equals mx, m being the constant of variation. So if y varies directly with x, and x is equal to 2, and y is equal to 14, then our constant of variation m is found by dividing the y by the x. And so with these values, we're taking 14 and dividing it by 2 to get a constant of variation equal to 7. The equation then that relates x and y, since y varies directly with x, is y equals 7x. So if I want to find two additional points that are on this line, y equals 7x, and the x is a -3, then I would put in -3 for the x. So when I substitute -3 for x, multiply it by my constant of variation, the answer is -21. And so the point -3, -21 is on that graph. If I want the x that goes with a y value of 28, then I'm going to put 28 into my variation equation. Since y varies directly with x, 28 is equal to 7x. Then to solve for x, I'm going to divide both sides by 7. And 28 divided by 7 is 4. And so when x is 4, y is 28. And these would be my 2 points on the line. Okay, in B, I'm told that K varies directly with J. So my equation is K equals M times J, where M is the constant of variation. That constant of variation is the change in the Y over the change in the X. In this instance, our Y value is the K, and our x value is the j, because y varies directly with x. K varies directly with I. So our slope or constant of variation is going to be k divided by j. K in this example is -8, and j in this example is 6. -8 divided by 6 simplifies to -4/3, and that is the constant of variation. So our equation relating j and k is equal to -4/3 times j, and that's our direct variation. If we want to find k when j is equal to 9, then we're going to put in or substitute 9 for the j. So that's a 9 over 1. 3 goes into 9 3 times. -4 times 3 is -12. And so k is equal to -12 when j is equal to 9. Okay, next we're asked to find j when k is 24. So this time we're going to put the 24 in place of the k in our direct variation equation. So 24 is equal to -4/3 times j. We're going to multiply both sides by the reciprocal of the coefficient on j. That's the reciprocal of our constant of variation. So the reciprocal of -4/3 is -3/4. Okay, 4 goes into 24 6 times. 6 times -3 is -18. And so j is equal to -18 when k is 24. So go ahead and pause the video here on your whiteboard or on some scratch paper. you're going to work out this problem where C varies directly with D, and you're going to write a direct variation equation that relates C and D. Then you're going to find C when D is equal to 2 and find the coordinates of another point on the line. C varies directly with D when C is -3 and D is -1. So go ahead and try that problem and then resume the video when you're ready to check your answer. Okay, so in our direct variation equation, since C varies directly with D, C is equal to the constant of variation times D. So to find that constant of variation, we take C, which is -3, we divide it by D, which is -1, and a negative divided by a negative is a positive. So our equation is going to be C equals 3 times D. Now, in order to find another point on the line, we can pick some values for C and some values for D. Okay, so to check that your point that you've chosen is on the line, you're going to calculate the constant of variation for the point and see that it matches your equation. So for instance, if you chose -5 as your D, then you put that into your constant of variation equation. 3 times -5 is -15. -15 divided by -5 is 3, the constant of variation. So we've shown that that works. That is another point on the line, right? If you take a look at this table and calculate your constant of variation for each of these C divided by D, you'll see that these are all valid points on that line.